Hello, Conf42. Thank you so much for joining my talk today. My name is Joe Skeen, and this is Falling in Love with Unit Testing. Buckle up. This is going to be a really intense talk, but I hope that you walk away with a lot more appreciation for unit testing, why it is that we're doing it, how to do it without making it a drudgery, and why we really shouldn't let AI write our unit tests for us. I've presented this talk in a few different flavors at different conferences using different programming languages. Since this is the DevOps conference, I'm going to be using PowerShell and Pester today in my code examples. But everything that I talk about are going to be universal principles that you can adapt to any programming language or unit testing framework that you happen to be using. So let's jump into it. If you'd like to follow along with the slides today, I have them posted out here. You can go ahead and follow that link and follow along with me. All right, so before we jump in too deep, we need to answer the question, what is unit testing? Unit testing is an automated test that validates your logic at the lowest level possible. So when you think about kind of the spectrum of testing, so to speak, you have your unit tests are going to be the ones that are testing the smallest parts. Then you have integration testing or API testing that will combine different parts of your program and validate that. Then you have your end-to-end tests above that, which have basically all of the parts of the program together. And then on top of that, you have manual testing. The thing that you need to remember about this is that the higher you go up on this pyramid, the more tests you have to write in order to validate all use cases. Think about that a second. If you have a system that is very complex, you will need to have an end-to-end test that covers every possible permutation and combination of use cases of every single feature of your app in order to have full test coverage. In order to do that with unit tests, however, because you're able to isolate each component into its own area and mock out dependencies and just focus on the logic, you can write many more tests which take a lot less code but give you a higher amount of assurance that you have actually covered all the use cases and that there aren't any edge cases out there waiting to, come back to bite you in the middle of the night. Been there, done that, not fun. So unit tests should be the basis of your automated testing strategy. That doesn't mean that you shouldn't have integration tests or end-to-end tests. Having some of those is often a good thing. However, if you are using end-to-end tests to make sure that you don't have to write unit tests, that's going to be a problem. Now, why is that a problem? Well, for that, I'm going to go to my personal definition of unit testing. And that is that unit testing is the process of aligning requirements with reality. Let that sink in a second. The process of aligning requirements with reality. In this talk, I'm going to be showing you my style of unit testing, which, for lack of a better term, I'm calling intuitive unit testing pattern. And I'm going to show you exactly how requirements are going to be tying directly to each and every one of your unit tests, and how you can take your unit test suite to a non-technical stakeholder and be able to show them, hey, these are the requirements for the application as I understand them. Am I correct? And you can sit down and talk through all of the edge cases that you have been able to test for. This will provide greater confidence between the stakeholder and the developer that everything has been coded correctly and that you are ready to ship whatever feature or product that you are building. If you think a little bit further, and this ties into the reason why we don't want to have AI write our tests for us. If you think about it, most of the time, if you are able to give an AI, like ChatGPT, for example, or GitHub Copilot, a description of the requirements for a function, it can spew out the code for you in any language you want. But in order to get really good code, you have to be really good at prompt engineering. In other words, being able to be very specific and telling the AI exactly what you expect as the outcome of the code. Well, if you take all of the time to do that, you have already done about 90% of unit testing. If you can define the requirements in a very plain and easy to understand and not easily confused way, you have basically written an outline for your unit test suite for the component or class or whatever function you are testing. We'll get into that in just a moment here. But I want you to think about that. We as developers are paid not because we can write code in whatever language, not because we can write the business logic. The AIs can do that for us now. But we are paid for our genuinely human, focused thought. And to turn the process of writing the tests over to an AI would be to lose out on a valuable opportunity that you as a developer can take to make sure that all of the requirements are well understood by you and that you can agree with the stakeholders what those requirements are. That is super crucial. And I think that unit testing, as a result, is one of, if not the most important skills for a serious software engineer to be able to have that mindset, being able to take requirements and break them down and be able to prove through automated tests that your code works the way that you think it does. Well, enough talk. Let's actually get into a practical example here. We'll do this thought exercise. And I like to decouple the ideas that I'm teaching about unit testing and the thought process that you go through. I like to decouple that from software in general, because this is really about reasoning with requirements. So we're going to talk about an object that hopefully everyone has experience with and can relate to. And that is going to be a door. Now, because this is a unit test that we are trying to achieve here, we don't want to try to tackle the entire door system at once. Instead, we want to find the smallest piece that can be interacted with and test that. So for that, I'm going to go with the privacy doorknob. This is the kind of doorknob that you may be able to find in on a bedroom door or a bathroom door pretty commonly. Some of them will have a turning mechanism for the lock or a button to push. This one we're just going to use this example that I grabbed off of Amazon of this door that has a knob on the outside, on the inside, a push button, and a latch bolt. And we will just focus on that and start talking about what kinds of requirements would you expect for this knob to be working properly. Okay, so we're going to start just by writing sentences that first define the thing, the what that we are testing, and then explain the when we are doing something to it, we want this result to happen. So our first sentence that we can use to describe the behavior is a privacy doorknob. When the push button is not pressed and the user turns the inside knob, should also turn the outside knob. Okay. Some of you may have seen sentences like this before using gherkin or cucumber syntax, and they will use like given, when, then statements to be able to describe this. You are more than welcome to use that style. I think it does help you to kind of think through the parts of that structured sentence, but I'm just going to use kind of a more natural language sentence for my examples here. So let's add another use case here. A privacy doorknob when the push button is not pressed and the user turns the inside knob should retract the latch bolt. So not only is the outside knob turning, but also the latch bolt is being retracted when you turn the knob. Okay, but what about if you turn it one way versus the other way? You need to always be thinking, am I being specific enough? In this case, there are two different ways that you can turn the knob, either clockwise or counterclockwise. And specifically, you expect the opposite side of the knob to be rotated the opposite direction with respect to an observer from that side of the door than the direction that you are turning the other side. So when the inside knob is turned clockwise, the outside knob should be turned counterclockwise, and vice versa. Okay, so we are going to just keep on piling on some more sentences here. So I believe we have both of those. A privacy doorknob when the push button is not pressed, when the user turns the outside knob should retract the latch bolt. Yes, we had that one already. And now we have both the clockwise and counterclockwise versions of those. And you can see at this point, we are getting to have quite a few test cases. And we haven't even really scratched the surface. There's a lot of other things we need to account for. And so this is where I like to take a step back. When you start getting overwhelmed, you start getting a little bit anxious about how many test cases you are authoring here. Take a step back, and we are going to apply some of our code quality principles that we already know and love, like dry, to these test cases. We don't want everything to be so overly wordy that we can't really scan through and understand what is happening and what the actual requirements are. So let's restructure it to reduce the duplication. We have a privacy doorknob when the push button is not pressed, when the user turns the inside knob clockwise, and then we have two different outcomes that we are expecting. Should also turn the outside knob counterclockwise and should retract the latch bolt. This format is way more palatable already, and allows you to kind of group things that are set up the same way. Now you will notice that we still have some of the results are duplicated, but that's okay because in this case, we need to be very specific about how we want those outcomes to be. And so it's better to remove the duplication at the beginning of the requirements and then have multiple expectations that may be similar, but should be really easy to reason with. And we'll see that in just a moment. Okay, with this new structure, we can now expand. We can look into other use cases, such as when you have the lock button pressed, well, you shouldn't be able to turn the outside knob, and you should be able to turn the inside knob, but when you do, it should pop the lock button back out. And so we're just continuing to iterate and to think about, okay, what are some other things that we could add to our behavioral specification for this doorknob component? Okay, so let's think about this also. What if the door is locked, but it's open, and someone tries to close the door, thus pushing against that latch bolt? Should the latch bolt stay stationary, or should it retract and allow you to close the door, even though the knob is in the locked state? So you need to think about that as well. There's also some exceptional use cases we should at least consider. What if the user exerts way too much force on the knob? Should it break? Should it, give in at a certain amount of stress? These are things that you should at least be aware of, even if there isn't a graceful solution for each one of these exceptional use cases. It may be okay to say that it breaks, right? But you need to at least be aware, okay, these are the ways that it can break, and I'm okay with that. Now, I said earlier that once you have all of your requirements together, you have 90% of your unit tests done. So I'm going to try to make good on that promise as we transition from this bulleted list of requirements to actual working unit tests. So we're going to be using this pattern called AAA, or Arrange, Act, Assert, to implement our unit tests. And we'll touch a little bit on that in a second. But basically, Arrange is all about what are the preconditions that need to be fulfilled in order to be able to run your test case. So all of those when statements in our requirements. There's the action, which is actually the last when statement. So when the knob is turned, this is the thing that we're not sure whether it's going to work properly or not, and so we need to test it. And then the assert is just about, observing the side effects or the return value or whatever result comes from that action that you just tested. So we're going to apply this to a doorknob that I wrote in PowerShell. Don't don't have to look too carefully at this because it's not really about the implementation here that's important. It's about, can your unit tests verify that the implementation is correct? And I personally don't write classes in PowerShell because there's a lot of gotchas there very often. And so this will just kind of be a sample here. Okay, so in Pester, which is the unit testing framework of choice for PowerShell, you have this really great describe, context, it structure that you can use. This is called behavior-driven development, when you're able to basically use these given, when, then type statements and turn them into tests. So we're going to fill them out. First of all, we'll just paste our outline there. And this is actually, admittedly, a part of the implementation that you could use AI to help with. You just don't want them touching any of these sentences here. But now we're down to code slinging, and AI is pretty good at that. But wait, because there's some patterns and gotchas that we're going to cover that you don't want to just let the AI go crazy unchecked. Okay, so we took that first bulleted list there. We have our outer describe. We've got a context block now for the when, and then the cool thing is you can nest these contexts as deep as you want to. So if you have when this happens, and this happens, and this happens, they can all have their own context. Then you have your 3 it statements here. And those are going to be kind of the leaves of your requirements tree. Okay, so we're just going to zoom in to this test case here and implement that using arrange, act, assert. So to arrange, there's a few things we need to do. First of all, we need to bring the code that we are trying to test into context. In PowerShell, we do that by sourcing that file into this file. Okay, next we're going to create an instance of that class that we've created. And then we are going to set the state that we want to test against. So this is a test where we're seeing if it's locked, someone tries to use the outside knob, it shouldn't turn. Okay, so the action is the person trying to do the thing, right? So we've got knob.turnOutsideKnob. knob. We're turning it clockwise. The result that comes out, checking the outside knob property, it should be null. And just to kind of, let's see, back on this one here, we've got this knob interaction result is kind of the data structure I put together for the output of this. So there may be an inside knob, an outside knob, or a latch bolt property on there describing what happened to them, whether the inside knob got rotated, the outside knob got rotated, the latch bolt was extended or retracted. So basically we come back here, and this is a pretty good arrange, act, assert implementation for our unit test. And it's pretty clear if you take a look at it what the different steps are. So we can take this and let's do it with the next 2 test cases. So this is the one that we did already. So the setup's going to be the same for this. So we .source that in. We create the instance. We press the button. We turn the outside knob. This time, instead of looking at the outside knob, we're looking at the inside knob. And that one should also not be turned. And then for the latch bolt, we do all the same things again, but instead we're going to be looking at the latch bolt property. It should remain extended. It should not retract when someone tries to open the door when it's locked. Okay, now this is where things start getting really cool, is that if you run pester, and I'm not using the default configuration, I'm telling it to use the detailed verbosity, which I really wish was the default, quite frankly. But look at what you get coming out of this. Describing a privacy doorknob, context when the push button is pressed, context when the user tries to turn the outside knob clockwise, should not turn the outside knob at all. This is our outline. It's come back out on the other side of the tests. And now we can say, yes, this particular requirement down to the T is fulfilled by our code. And this is the really exciting thing, is when you can start seeing a bunch of these stacking up and being able to see all of your requirements coming to life. Okay, but it's not all sunshine and roses, because if we look here, we have all this duplicated code here. And if we start getting to tens and hundreds of unit tests, having all this extra noise here that's duplicated makes it way harder to maintain these tests, especially since we've already kind of established that all the tests within this context here should have a doorknob, and it should have the button pressed already. And so how do we deduplicate this? We're going to do some dry principles here, and this is where you get to use before each loops, or before each statements or functions. And this is really where we go from normal unit tests to what I like to call intuitive unit testing. So we're going to create a before each block on every single one of these blocks here. Not inside the it, because there's only one of those. You can't have anything nested inside of an it. But inside these before eaches, we want to define anything, or do any of the setup that is required to fulfill what is right above it here. So a privacy doorknob. In order to have this fulfilled, we actually need an instance of a privacy doorknob. So that means we need these two lines in our before each. So we got that. And now we should be able to get rid of all of that duplication in the other test cases. Okay. And we got some extra code there that I needed to clean up there. Okay, so we've got our arrange. We still have knob.press button, and you'll notice that is defined here. So we should do that in the before each right here. So we're going to move that up here. And now look at that. Our arrange block is completely gone there. That's weird. Okay. Let's go ahead and clean all that up. Okay, and now the next thing that's duplicated is this when the user tries to turn the outside knob clockwise. So we could put that in here. Now, the one thing that I don't like about this is we're kind of just treating this as if it's just another before each, which is kind of like our arrange part of our unit test. And I'd like to be a little bit more specific and actually point to the fact that this is the action. Yeah, and you can throw a comment on that. Yeah, I guess that makes sense. You could do act here, right? But then you'd have to like go like arrange and arrange, right? Another way I like to do it is to just define the action as a function, or in PowerShell's case, a script block that you can call whenever you are ready for that. And so we have different actions that we can do. You know, maybe we do the outside knob here, but inside this context, we could also do the inside knob. But this is where we're actually defining our action. And sometimes that might be at the very top, depending on how your test is structured, if you're testing a class versus just a function or a script file. But since this is where we are basically saying what the action is, this is where the before each is, and I'm just going to put action equals, and I'm going to put a script block here. And so I'm going to paste that into there, and then we can say invoke expression, or sorry, it's invoke command script block action. And that's how you run a script block. So here it doesn't make quite as much sense because like we just define it here and then we immediately call it. But if you had this action defined up here, because you were only testing a single function, but then you had a bunch of different setup steps, it would be nice to say, this is my action, it's already out of the way, and then I don't have to worry about it until I'm ready to basically execute that action. Okay? So I'm going to put that back like this, since that's not the case for this particular test suite. And another thing that we probably will want to do, and I can go through and clean these up, you can see that we've basically gone from, what was it, like 8 to 12 lines per test case. We're down to just one in each it, and it's just a single assert that ties into this statement here, should not turn the outside knob at all, and you're just basically translating that statement into code as an assertion. Okay, one of the other things that I'll generally do, and this is very specific to Pester, is that sometimes the scope between these different script blocks can get kind of weird. In earlier versions of Pester, you could define things outside here, like my var equals 2. I promise I can type. But in the latest versions of Pester, this will basically be completely invisible to your tests. All it will see are things that are inside your before each and your it. And that's it. So because of the PS script analyzer saying, oh no, your things aren't being used, and I can't remember, maybe sometimes it actually doesn't carry over the scope the way that I expect it to, I like to turn these variables into script scoped, which means that these variables will live during the entire lifetime of this script file. And so you don't have to worry if you're in a script block or in some other weird situation. You can just put script on there, and then now you don't have to worry about the scoping of those variables. Okay, and then I'll bring script onto here as well so that we don't have to worry about the scoping there. Oops. And paste. There we go. Okay, so this is good. To generalize it just a little bit further, I like to use some terms. So we've already got action here for that, to kind of identify this is the action part of our arrange act assert. But you also can do some other things, like instead of calling this script knob, you can be a little bit more descriptive in the testing vernacular and say that this is our subject under test, SUT. And so that is saying that in this test case, this is the test subject. It is the thing that we are going to be acting on in our action. And so that's kind of a good, like, checking over things and making sure that things are right. Does your action function or script block call something on the subject under test? If not, you might be accidentally testing your own test or testing your own mocks, which will lead to a lot of problems there. And then, yeah, this is just a nice way of assigning a variable outside of that you can assert against. So this is pretty cool. And with this in place, we really could continue to implement the rest of these really, really easily, as long as we keep putting in those before each blocks where they make sense, and things just kind of become very intuitive and very easy to implement as far as the testing is concerned. Things are not cluttered, things are not duplicate. You can come through here. If you were to get a test failure, you would know exactly where to go and what was failing and why, without having to interpret lots of error messages. So to recap, the intuitive testing pattern, as it applies to PowerShell and Pester, is you always want to have a before each block inside of each, right inside of each describe, inside of each context. And this is where you're going to do all of your arrange steps and define your action. And once you've gotten to the point where you are to the innermost context, you can invoke that action. The its should be one-liners, if at all possible. Even though it's possible to have lots of different assertions in the same test, it's not great. It would be better to make an it that has a good description as the name, and then have a one-liner expectation. It does take a little bit of getting used to think about writing tests this way, but I've found that this, whether I'm writing in PowerShell or JavaScript or C# or whatever language I happen to be working in that day, this pattern works really, really well and will help you to be very successful when testing. So I hope you now understand why it is that we don't want to just hand over the task of unit testing to an AI. If I were to go to ChatGPT right now and tell it to write me a unit test suite for a doorknob, it is unlikely that we would get the same level of maintainability in the output, because a lot of the training data is based on unit tests that were not written this way. And unfortunately, one of the big barriers to unit testing is the precedent of a lot of duplicate code, a lot of test names that don't actually tie to requirements, but is like something like test one, right? I know you've seen that in code bases before. I've seen it so many places. That is the input for the AIs. And until the AIs are trained in how to write tests in an intuitive way like this, I wouldn't trust the AI to write your tests for you. But again, the requirements gathering step, regardless of how well the AI can churn out the code in the right format, you want to be in charge of your product's requirements. That is why you are a human and not a computer writing software. Before we wrap up, let's talk about one more important thing, which is how to make sure that you don't over-test, making superfluous test cases that don't actually add any actual value to your confidence level. Let's consider this PowerShell function called remove vowel. Takes in a string that is the input, and it'll output a string that is the same as the input string, but having removed any vowel characters. Okay, so the things that you should be testing: empty string as kind of a test, a boundary case. Yeah, what if somebody passes in null or an empty value, or just a value with nothing but white space in it, right? You should test a small string with some vowels, a small string with only vowels, a small string with no vowels, a very large string, make sure that performance-wise it doesn't have problems. And then you can also throw in a string with complex Unicode characters like emoji or other languages that you wouldn't necessarily expect, but you should know what's going to happen if you throw something like that at you. The world is getting a lot more international every day, and you should be not just thinking about your current locale. But that being said, you don't see in this list that we should test it with every possible combination of letters, right? That's not really feasible. It doesn't make sense to do that. Instead, you're looking at classes of input and making sure that you have a test case that will cover each of those classes of input. Okay? So with that, I know that there is so much more that we could cover. We've just barely scratched the surface, but what I really wanted to do today was help you to understand how unit testing can actually be an exciting and fun thing to do rather than feeling like it's a chore. But yeah, we could have easily gone over like how to implement this in continuous integration and continuous deployment pipelines, as this is a DevOps conference. But I felt like this probably will benefit you guys more in the long term if you get this idea that unit testing is important and it's fun. And you're not going to be perfect at it right away. Try going through the same process that we've gone through today with the doorknob and going from distilling your requirements down to arrange, act, assert, and finally into the intuitive testing patterns that we've demonstrated here. Just keep on practicing and you'll get better and your code will get better. You'll start thinking about those edge cases a lot more than you did previously, and your code's going to be a whole lot more robust. So thank you so much for watching. Again, feel free to contact me. I basically do this kind of thing full time, helping out other developers learn how to up their skills and up their game. And so feel free to reach out, and I'd be happy to repeat some of this and tailor it to your specific team's needs if you would like something like that. Again, thank you for Conf42 for letting me speak here, and I hope you guys have a great time at the rest of the conference, and good luck unit testing. See ya.